Hello and welcome to another video tutorial in the game development series. In this tutorial, I'll be showing you how to add keyboard controls to our existing game engine. With the keyboard, we'll be able to move forward and back as well as left and right, in addition to being able to turn either left or right, so we'll be able to move around in the scene just a little bit. In the next tutorial, I'll be showing you how to add mouse commands to navigate as well, so we'll be able to look around using the mouse. But for this tutorial, we're just going to be covering the keyboard. Now, if you find my tutorials helpful and you'd like to support my website, please go to www.maticnose.com and you can support my website by either clicking on the PayPal icon and donating some money, or you can click on the ads, the Google ads, which are shown on the right side of my screen. Okay, so last time what we've done is we created a camera class which we used to sort of position the camera in 3D space as well as orient it, so it's pointing in a specific direction. And we see here that in the pre-render function call, what we do at the very end is we rotate our camera by whatever angle is stored in the camera class, and then we translate it using the X, Y, and Z values stored in the camera class. Well, now what we're going to be doing is adding keyboard controls into the engine so that as we press the keyboard controls, we can then update the X, Y, Z position so we can move around, as well as we'll be able to update this angle, so then every time through our loop in our game engine, the camera will move, thus allowing us to see different things in the 3D world. The first thing we'll need to do to be able to respond to key presses on the keyboard is we need to create a new variable that will store values for each of the keys. So what we'll do is we'll create an array that stores the state of every key on the keyboard, and then every time a key is pressed, we'll update the variable that stores the identification for that key. So to do that, let's go into the game OpenGL.h file. And just at the bottom here, we'll create a Boolean array, and we'll call it keys, and make it 256 keys wide. So what this will do is it's going to store the state of 256 keyboard keys. Now we choose 256 here because a standard keyboard will have somewhere around 101, maybe 105 keys. But if you add the shift to each of those keys, then you can double that, so you have around 220 keys. Then there's the other keys which international keyboards may have. So in total, there should be around 256 keys that are possible to be pressed. So now that we have a variable to store the state for every key on the keyboard, let's go initialize this member variable in the constructor. So that's under the game OpenGL constructor, and at the bottom here we can just set every value of that variable to be false. So initially none of the keys are being pressed. Okay, now that we have this variable initialized, we need to be able to update this whenever a key is pressed on the keyboard. And to do that, we can go into the message handler, and Windows will happen to send a message to us whenever a key is pressed on the keyboard. And the message it will send is either one of the following. It will be either WM_key down or WM_key up. So it sends key down whenever you press on a key on the keyboard, and when you release a key, then it will send key up. If you press and hold the key down, if you press and hold a keyboard key down on the keyboard, then this message will start being sent to your window multiple times, and it's going to repeat at a certain rate. So that's one thing to remember. So as you can see here, what we do is as soon as the keyboard is pressed, as soon as the key is pressed on the keyboard, then the key that is pressed, we take the parameter for that key and we set that our member variable to be true for that parameter. Now, as a little bit more of an explanation on this, we can go into MSDN and just look up WM key down. And if you read through the documentation here, you'll see that WM or WParam here specifies the virtual key code that is being pressed. And then lparam you can use to determine whether other things are being pressed as well, like an alt key or a control key. So for now we're not concerned with that, we're just mainly concerned whether the person's pressed the key down. So let's go back into the code now. Okay, so when a key is pressed down, we set it to true. When it's pressed up, we go and set that value to false. So this value will only be true whenever a key is pressed down. Okay, so now that we know when a key is pressed down, we need to do something. Well, we're going to create a function. So let's go into the .h file here, and I'll put it right here, and I'll call it handle keyboard. Now, this function is going to be called whenever we want to perform some sort of action whenever a key is pressed on the keyboard. And we got to go put this code in our CPP file. So let's do that. Okay, so we want to respond to the keyboard every frame, so it makes sense to put the handle keyboard function call inside frame. And we'll do it right after we get the total time here. Because, as a matter of fact, we need to know how much total time has passed since the last time we went into the frame, because there's certain keyboard events will be time dependent. So here you see we're passing in the variable for the change in time into our handle keyboard. Okay, let me go back to the message handler here for a second. And back here, when we're talking about the WM key down event, in MSDN it's specified that a specific virtual key code is pressed. What is a virtual key code? If we go into here and we type VK for virtual key code, we'll notice that there's a listing of a whole bunch of these key codes. These are the key codes that are represented by the keys on the keyboard. So you can see if we receive WK_return, that means that someone pressed the enter key. If we receive WK_escape, someone pressed the escape key, and so on. So there's all these key codes that have been predefined for us, but there are a number that haven't been predefined. So you notice number 30 here, well, the key code number 30 represents the 0 key on the keyboard, but there is an actual virtual key code associated with 0. And all the way down here, these are undefined, and then we have the alphabetic letters here. And again, those ones do not have a virtual key code defined. So what we're going to do is we're going to go into the core, into the .h file here, and create virtual key codes for all those missing virtual keys, like this. So you see here, I'm creating a virtual key underscore key 0, so this is going to represent the 0 key on the keyboard being pressed, and I set it to number value 30 in hex. And again, if we go back here, number value 30 in hex represents the 0 key. So I just went through and I extracted all the numbers here for all the numbers from 0 to 9, as well as all the letters from A all the way down to Z, and got these numbers, and then once I had the numbers, I just defined them all using just define statements here for all the letters and numbers. Now that we have that, we can go and write the function call for handle keyboard. Now I'm going to put that function call just after frame, since it's going to be called by the frame. So here it is here. And you can see what I do is I check to see if a specific key is pressed. So in this first if statement, if the up key is being pressed, then this happens to be a virtual key code that has already been defined for us. I didn't define this one. It was done for us in the compiler. So if up is being pressed, then what I do is I say, take the camera and move it forward by some value, and I pass in the delta time that we get passed in here for the handling the keyboard. And then the camera does the motion for us, or the camera class. Same thing for the W key. So you can use either the up arrow or the W key on the keyboard to move forward. To move down, you can press the down arrow or the S key. To move left, you have to press the left arrow or the A key on the keyboard. To move right, we can press the right arrow or the D key. And then to turn, I've allowed the user to turn by pressing the Q key or the E key. So you can see the code here. And that's about it, I think, for getting the keyboard to work. So let's go and try it out now. Let's build and run. Alright, so now you see as I'm pressing the keyboard forward, I'm moving forward in scene, and back, I'm moving back. If I press left, I move left, and I press right and I move right. Now you can see that I'm moving really quickly in the scene, so it's very jerky. Now we can change that by going into the camera class and changing some parameters. So in the constructor here, we have the speed, units per second, as well as radians per second for turning. Let's lower these numbers to something more reasonable. Let's say 5 and, I don't know, let's try 2. And build that. That should give us a more smooth control using the keyboard. Okay, so now I can press and hold, and you can see I'm moving forward and back, left and right, and then turning. Okay, so that seems to be working. Now I want to point something out that's very important. I have my triangles here. I'm going to move forward in the scene, and I'm just going to turn around. Notice there's this purple triangle here on the screen. Where did it come from? I'm going to move forward through the triangle, and then turn around again. There is no purple triangle. Well, the reason why I have this on the screen is because these triangles are single-sided, meaning if you look at the triangle from the back side, you won't see it. It'll be invisible. And as a matter of fact, if I were to go to the right, beyond, notice this green and purple triangle here. If I go beyond it, it disappears. And then if I turn, you see I don't see that triangle anymore because I'm actually standing behind it. And what I've done, you can see here, is I placed a purple triangle right here that is invisible to us when we start, but it's visible when I turn around and look at it from the other side. Same thing with the red one here. If I go too far to the one side, it turns invisible. So that's one thing you have to be sort of careful of when you work with 3D graphics, because I do have backface calling turned on, which means only render one side of the triangle. Now, this is very helpful because if you render only one side of the triangle, then you're actually speeding up the amount of processor power that your graphics card can have. If you render both sides of a triangle, you're basically wasting half of those render calls because you can only ever see one half side of the triangle. So that's why we choose to use backface calling. Now, whenever you want to create solid objects, you have to make sure that they're fully enclosed so that you can't see them from the back side. And that's very important whenever creating 3D models and things like that. So something to be careful with, but not too difficult once you understand the reason for it. Okay, there's one other thing I wanted to point out to you, and that's back in the render pre. Notice that when we created this camera here, we always rotate the camera first and then we move it. Well, let's take a look at what happens if we reverse these. If we move it first and then we rotate it. We can move forward and back. Everything seems to be fine. I can move left and right. But now watch what happens when I rotate. I'm rotating to the right and I'm rotating to the left. That seems okay. But now, if I'm moving left and right and forward and back, the motion isn't correct. And as a matter of fact, if I rotate, you notice I'm rotating not about my own point, but about a point that has been offset. So everything is kind of messed up. So this is actually the same cause of the problem that we saw earlier, where when we're rendering one triangle on the screen and then rendering a small triangle, the small triangle wasn't rotating about its own point, it was rotating about the center. Well, that's the same thing that's happening here. We have to make sure that when we use the camera, we first rotate the camera about the center, and then we move the camera off away from the center. It's very important the order that you do this in. Now this will come into more of a important issue when we start adding mouse commands to rotate the camera, which is going to be in the next tutorial. So I hope you come back for the next tutorial to see how to add the mouse commands.